So I'm really excited to be here with you at Nodes 2024. I've been involved in the graph community a long time, and every year things just keep getting more exciting and more, amazing applications. And it's really been amazing seeing all the other sessions and whatnot. And today I'm very excited to speak with you about something that I've been working on for a while now, and it's this idea of a personal knowledge vault. For the past year or so, I've been plugging away on this, and it's with a specific purpose. So I have a relative who's been diagnosed with Alzheimer's, and they're in the process of trying to write their memoirs. So part of what I wanted to do was, they have some functional memory impairments that makes it difficult for them to work on a computer. So part of the idea behind this is that I believe with the advent of AI and with the power that's in the Neo4j graph database, it affords the opportunity to create a much simpler set of interactions to help people in this sort of situation, work with machines in a whole new way, so that make it a lot easier for them to kind of capture memories while we still have the opportunity to do that. So today I'm going to speak a bit about the application itself. I'm also very pleased to be able to release the source code as well for this. The links will be posted for that. And you'll be able to go check out the back end for this, and I'll go into some of the ideas as to why I've undertaken this initiative and some of the thinking behind it. So a bit of an introduction. So as I mentioned, I've been in the world of graphs quite a while. I think it's an amazing technology. I think it has incredible use cases. Throughout my career, I've been involved in quite a number of different domains and segments. My main focus, though, is in applying technology to challenges in the engineering, environmental, AEC, and energy domains. And I have done some work as well on the financial side of things. I first ran into Neo4j, I think in about 2010, when I was working at an environmental company, and we were looking for ways of being able to bring together complex data sets that are associated with physical models that exist in that world. Through that work, I founded a company called Menome Technologies in 2016 that was focused on simplifying complex data sets and providing actionable insights out of that. That company was acquired by Arcurve, where I now work, with a team of amazing people. And I'm an advisor to executives and whatnot in the context of the role that I do now on the application of pragmatic technology, in particular AI and ML, into solving complex challenges in organizations with a focus on, engineering, mining, energy companies, and those sorts of applied things. I also live in Calgary, Canada, so it's a pretty amazing place to be because we have access to incredible mountains for skiing and mountain biking, which you see here. And more recently, I've been having quite a bit of fun performing music with my daughter, and also working on some cool side projects with some AI-related music video technology. Okay, on to the specifics. So, as mentioned, what I've observed over the years is that it's very difficult for anybody these days to work with. Even sophisticated users have a hard time finding knowledge and working with knowledge in the machines and through the metaphors that we have with us currently. And I'm going to go into a little bit of background as to why that is. So when you think about this, and when you try and work with somebody who has functional memory challenges, you can just imagine how hard it would be and is for a person in this place to try and find the files that they need, to try and write and create documents, to try and capture memories. And it gets down to the simple fact that machines, until very recently, have not been able to interpret human commands. And the reason for this gets into some history. So back before all the technology that we have now and the metaphors that we work with now came into inception, there was some really amazing thinking around the way that these machines were going to work. The limits of the technology at the time limited the vision, the ability for these folks that you see here to implement the vision. And this sort of culminated, prior to the work that was done in this world. Of course, most of the way you'd interact with computers, such as my first computer that you see here behind me, was on the command line, which meant that you had to learn a whole bunch of Byzantine and fairly complex arcane commands to be able to get the computer to do anything. So Alan Kay and the folks that came before him came up with this amazing visual metaphor that was the desktop metaphor with the icons and the windows and the things we're all familiar with, to enable more people to work with machines than was possible with just a keyboard-based and command line-based thing. And I know Emil likes that world, as do I, but not everybody's amenable to it. So then Steve Jobs and Apple, of course, as the story everybody knows, took that insight that was the metaphor that was generated at Xerox PARC Labs, commercialized it, and made it broadly available to many, many more people, which was quite a revolution at the time. But again, we're stuck with this idea of limited machine intelligence. And this desktop metaphor that we see and are so familiar with its apps and its windows and its mice and its icons, while an incredible revolution at the time that it came out in 1984, or was broadly made available in 1984 based on the work that was done in 1972 at Xerox by Alan Kay and his team, it still requires this idea that you're using metaphors to translate human interactions into machine understandable commands. And what's happened over time is, as our machines have become immensely more powerful and we've got these incredible mobile devices, but the way we work with computers has fundamentally not changed since basically 1972, which has resulted in massive amounts of complexity, a veritable explosion of apps. The average user has 40 apps installed on their mobile phone. Somebody working in a company has to interact, this is a study done by Harvard Business Review, to execute a typical transaction through a supply chain, something like processing an invoice, for example, switching 350 times between 22 different applications and unique websites just to get a single business process done. We live with incredible complexity. Now, on top of that, you then have this proliferation of clouds and software as a service systems. And this makes it extremely difficult while the cloud has made things simpler in some senses, in that we don't have to all be IT geniuses to run things. For the average person working on a machine, and I've observed this, where, again, person trying to write memoirs on a Mac wants to grab the stuff and put it into iCloud. They use Office. So, of course, what does Office do? Well, hey, guess what? You're going to get stuff put into SharePoint. Outlook, complicated thing to use, trying to manage your email. And then, of course, I challenge anybody to find anything in SharePoint. It's a very difficult system to use. Good Firm's survey that I found, 54% of respondents to the survey used 3 different cloud platforms. So you start thinking about this, and I've observed this. Which version of the document did I just write? Where did it get stored? Is it in this cloud? Is it in that cloud? What's my password? How do I get into this thing? What version of the document is the most recent one? These are all very, very hard problems for a normal person to solve, let alone someone who may not be able to remember where they put something. And again, a lot of this has to do, certainly this is the commercialization piece, but a lot of this has to do with limited machine intelligence, which has meant that people are forced to interface machines. We have to learn how the computers work rather than the computers learning how we work. And this is the opportunity that I believe AI really affords us, is that we now have a generational opportunity, we're at a very unique time and a very unique place where all of a sudden machines are starting to be able to understand human intent and human commands. We can translate human instructions into things that machines can understand. And when you factor AI agents and agentic AI on top of that, and myself and some of my colleagues at Arcurve have done a number of lectures on this subject, these AI agents are an incredible way of taking away the complexity by having the AI agent conditioned to understand that it's got a set of tools that it can access, so that when a user gives it a request, the agent can grab that request, interpret it, figure out which tools it needs to use, and then transcribe that request into the language that the various different APIs and backend systems need to understand to be able to interact with them. It can collate and synthesize the response and then give that back to the user. So instead of, for example, trying to book a vacation inside of a company where you have to go into the HR system, fill out a form, submit that form, that goes through a workflow process with a bunch of approvals that you have to follow. You then have to go into your calendar and book a vacation, and to let people know you're away. And then you have to let your project management team know through the project control system. You can just tell an agent, hey, I'm going away at the end of November. The agents go and they do all this stuff for you, and they say, hey, you're good to go. Same sort of thing on the knowledge front. And this gets us to our specific use case. where what I'm seeking to do is I'm specifically helping a person with functional memory challenges work with their knowledge by using natural human interactions. And there's three things I really want to accomplish with this, and that's access a computer without needing to access knowledge without needing to use a computer. AI agents are set up in the background to make it easy to capture, retrieve knowledge very quickly and easily, capture, store, and recall notes. Because when you're sitting talking to somebody and they're remembering things, the context allows, oh, hey, I remember the time that this and this happened. The last thing you want to do is to pull out a computer and get them to type that in. Much easier to just fire up your smartphone, fire up ChatGPT and go, hey, record this, and just let them talk to the thing, and then it grabs that knowledge and puts it into the knowledge graph. The technology that I'm using, so switching into, now we're going to start going into the system itself a little bit. I'll show you a couple of examples, but we only have 30 minutes, so I got to go really quickly here. But there are, I've got some other sessions that you can look at that have more details. So we are leveraging AI agents granted by Neo4j graph database technology. And, certainly I believe that Neo4j and the graph paradigm is the best way of anchoring LLMs into context. The other thing that's really important with this is because we are dealing with personal private information, I don't want this stuff leaking out all over the place. So I've also set up a private file store using Mini.io, which is an S3 compliant storage container that then is hooked up to the rest of the API layer. Again, Alzheimer's, once it's diagnosed, progresses quickly, so I don't have a lot of time to get this working. So that's why I'm using GTP and ChatGPT to get the interaction layer set up. I can harness all the stuff that's inside of OpenAI's environment for the interaction bits and not have to write a user interface for this, although I intend to do that at some point. And then I can deploy this in all the various systems that the person is using so that they've got access to this setup without me having to kind of worry about all of those bits. These are the operations supported. Again, I'm providing the source code for this. The links will be put in the chat here, so you'll be able to go get that, and you can have a look at these in more detail. Let's get into some examples. So some of the things that I know there's been, I think in the fireside chat, they mentioned some of the stuff about, looking for use cases, and there's all sorts of exploration going on in this domain, and enterprises are, I think Emma was talking about this, where he mentioned the fact that, executives say, hey, we need AI, let's go make an AI thing. And people kind of truck around doing different things. The stuff that excites me about this and that we see as being really, really useful for enterprises, so really comes down to a couple things. One is simplifying interactions with complex systems using agents. That is an absolutely essential and killer use case. The second thing is making data that has been largely inaccessible, accessible in very simple ways. Handwriting. The OpenAI 4.0 model, the Omni model, is incredible at handwriting recognition. And this is my handwriting. I'm going to show you this working here in a sec. It can actually read my handwriting, which blows my mind. That's the first time I've ever seen any system be able to do that kind of thing. So being able to extract knowledge out of documents like this, out of field documents, out of notes, and being able to capture voice, all this sort of thing is an incredibly powerful use case. Then being able to take that stuff and break it down into a graph structure, and I use a graph document structure that looks like this, is a very, very powerful thing. So all the, Gen AI, great, people can charge after that. The stuff that gets me excited is this. I can get access to data in an easy way that I wasn't able to get access to before. All right, let's check this out. So up here, we've got our ChatGPT with Mike's personal knowledge vault. There's a GTP that sits inside of this. I've made that code available in the source code as well. Not going to get into details about how that works specifically in here, in the interest of time. Down below here, we've got the command. This is showing the API as it runs. So then I'm going to tell it to execute this command here. And if the demo gods are with me, what we should see happening is our friend ChatGPT will take this information in this little note. You'll see this thing think for a second. It'll start the action. This will chug away for a bit, and then it should ask me to confirm that. Once I confirm it, what we should start to see down here is it'll kick off a whole pile of processes. Now, what's going on here is that has now extracted the text from that document, and it's triggered my API. And you'll notice that it's now kicked off what I'm calling the celery background process. So the API that I've set up has a couple parts to it. One of them is a backend processor that allows that when it's triggered, it will actually take that incoming document. It'll create a document node. Actually, I'll show that to you in the graph. There we go. That's the node document coming in there. So what that does is that'll extract the text out of the document, and you'll see that it is pretty incredible. Basically nailed it. Still blows my mind. And then the agents in behind the scenes will take the text. It'll trigger a sub process that runs in Celery at the background, so it's asynchronous. That way it doesn't block if the person's still trying to interact with this thing, because some of these document processes can be quite long. That breaks the document down into pages, chunks, generates questions, generates summaries, and then I have another sub process that generates categories out of that using natural language processing and that kind of thing. A lot of this work is based on the work that Thomas Britanniak has written up, so you can have a look at his blog posts, for which I provide links for. Retrieval. So on the retrieval side, I've got a couple of agents in there. One that is designed to find documents. I need to find this thing that I wrote 3 months ago, blah, blah, blah. That one uses a React tool agent-based pattern. So if I wanted to find the document that I put in about the field observations, what this does is this is conditioned to take that statement, and then again, this is based on a blog post that Thomas did recently, where there's a bunch of tools that sit in behind this single tool pattern. The React agent basically can take the statement coming in, interpret it as being a find request. That find request then maps the parameters that it observes inside of the request, which you'll see coming in down here. So we should see the description is brine contamination. That goes after the vector index search. In this case, you'll see the date range was extracted out of this, even though it transforms these sort of language statements into date statements, executes the search, and then there's our document coming back here. And then I can do things like get note on display full text and image note. So again, if the demo gods are with me, I wonder what a demo god looks like. What we should see is the note ID is correct, and then here we should see it going to get that note. We should see the note coming back up. There it is there, and then you'll see this is the image coming back out of the Minio container, and there it is. Awesome. So this is the type of interaction we want to make, something where the person can communicate with the system, not having to push buttons, not having to figure out which icon to select, not having to know which system to go to. You ask the thing a question, it responds. It goes and gets the knowledge out of the knowledge graph. Another pattern that I've got in here is the question and answer pattern. So this uses a different React agent that has conditioned with 4 different tools. And again, this also shows why graphs are incredibly useful and important for this type of a use case. Because of the fact we can have a bunch of different tools, and we can have it go after different sources, and we can have it understand that based on the context. This is a chain of thought agent. So what it does is you'll see down here is it'll trigger that off, and it'll go, hey, I need to figure out whether this is, I need to classify the question to understand which tool I should use. This is a general question I'm going to use, and I told it has to go after my internal knowledge vault first, which it does. It goes back and it pulls back the documents that it's found out of the vault, which you see here. That's the response. It will assess the final answer, and it goes, great. Now, the other thing that this does, it's super important, and again, I think this was mentioned by the panel this morning as well, is that whether you're talking about this use case or an enterprise use case, context is critical. So I need to know when I'm setting this up at an enterprise, as a person with this type of a knowledge system, what the sources are, how the tool came about its answer. And the beautiful thing about this is that this system can do that. Here are the tools that it used. It used the internal general answer search. These are the thoughts and observations the tool used to get this. Here are the sources that it used to generate this response. I can also do things like, okay, this tool is conditioned. So if I ask it a geology question, so what you're seeing here is this is a knowledge base that I use for myself. Everything that I read goes into it. And of course, it doesn't have any geology stuff in there, although I do have a geology background. I haven't typically been keeping up on the latest news on chalcopyrite. So what we should see here is this thing should not find any information about chalcopyrite in it. And there we go. I'm sorry, but the provided content does not contain any specific information about the mineral chalcopyrite, but it's smart enough to know that it has a tool called Tably that it can use. When it can't find anything internally, it will then go use that tool to search Tably, which is an AI-based search gizmo, to then pull back the information. It will tell you that it did this, and it will give you the references. Finally, we have a research agent, and again, it was set up in the context of working with the person for the memoirs, where it's like, oh, I remember this thing, but this event that happened, but I need to get more information about it. So this agent, and I won't go into details here because I know I'm running out of time. Basically, what it does is it's a land graph agent that has the ability to take a topic, and then it goes out, checks the internal knowledge repository, checks the internal one, collates a bunch of information together on the topic. It has a designer and a writer and a critiquer that go through a set of loops to then construct an output and then returns that back to the user. In the context of the way it works, it actually generates, and this is really, again, another very important point about how understanding and grounding responses in context and understanding where that comes from. What this agent does is LangGraph is a graph. Neo4j stores graphs. So I was able to take the steps that the agents are going through from the graph. This is the same exact code that if you look at the Python code, you'll see that these agents are in the code. I can then see exactly which external documents based on the relationship. That's a new document. This is an internal document, and it referenced that specific page. You can also see the steps that the critique agent took. So we should see here, the critique agent is designed to challenge the writer and editor agents to say, okay, you need to clarify the technical terms, blah, blah, blah. Here's my feedback. That will go through another loop before it then passes through. This stuff, like for being able to keep track of what these agents are doing in a complex workflow system, Neo4j is the way to do this. There is no question.